Okay, hey everybody, we're going to learn about gas exchange. So whenever we talked about alveoli, the alveoli sit right next to the capillary, and we said that they each had one cell thick. So the alveoli has one cell layer around it, and then the capillary has one cell layer around it. And we call this the respiratory zone because this allows the gases to be exchanged very easily. So the alveoli is made up of epithelial cells. Remember, those are the squamous cells. And our capillary is made up of endothelium cells, which again, just one layer that makes up the inside of all your vessels. But capillaries, that's all they're made of. And they're fused together so that your gases can move really easily. So during gas exchange, it's a little tricky and it involves some chemistry because your oxygen, when you breathe in your oxygen, you take a deep breath, you have it as a gas. It's found as a gas in a mixture of gases inside of your lungs. And it has to then be absorbed into your body into a liquid. And so that movement from a mixture of one type of phase as a gas to a second type of phase, a liquid, requires a little bit of knowledge about chemistry. So it's not as simple as something like we've been talking about with diffusion, where it would go from diffuse across a membrane from one liquid to another. And carbon dioxide, remember, it's coming from your blood and it's leaving and entering the air in your alveoli. So again, it has to go from a liquid mixture into a gas mixture. So in order to understand this, we have to learn about Henry's law. And Henry's law basically says that it's basically like diffusion. So whenever you have a gas inside of a group of gases and it comes in contact with a liquid, your gas will move into the liquid until it reaches equilibrium. So just like we talked about before, it'll go from a high concentration to a low concentration until their concentrations are the same. Now, what makes it a little tricky though is that the gas has to be able to dissolve into the liquid. It has to be soluble. So the solubility of the gas depends on what kind of gases you are moving. And that's where we get into the differences. So CO2, or carbon dioxide, is the most soluble. It'll move between the gas and the liquid easily on its own. It's very independent. It doesn't need any help. Oxygen, though, is only 1/20th as soluble, so it needs a little bit of help. And if you think back to our blood unit, what helps oxygen move around in the blood? It's hemoglobin. Hemoglobin is on your red blood cells. So your hemoglobin is a little carrier for your oxygen. So as oxygen diffuses into the plasma, it's held onto by that hemoglobin to help it become more soluble. Now, when you breathe in and out, the majority of the gas that actually goes in your lungs is nitrogen. That's N2. And N2 is not soluble at all. You actually need nitrogen in your body for things like proteins and DNA and RNA, but you don't have the ability to get it through breathing because nitrogen will not dissolve into your bloodstream. So all the N2 that you breathe in, you just breathe it right back out, and then you have to get your nitrogen by eating food. Okay, so now we're into the physiology, and you will have to explain this on your test as an essay question, and you're going to get some flashcards that go through this too. So basically, it involves a little bit of chemistry, and a lot of this we've talked about before, so it should be pretty familiar to you. So the first thing, we have our tissues, and our tissues are going through cellular respiration. And cellular respiration, cellular, what does that mean? It happens at the cell, right? And then respiration means your gas exchange. So you're bringing in oxygen to feed your cells, and what are your cells using oxygen for? Energy. They want to get energy. So you're going to use your oxygen to make energy, and in the process you're making CO2 for your waste. So your tissues went through this and they used up all their oxygen. So now we have a low concentration of oxygen and we have a high concentration of CO2. So CO2, remember, is a very independent guy. He doesn't really need any help doing anything. So he's going to diffuse easily from the tissue into the blood. CO2 is also really reactive. So once it enters the bloodstream, it actually is going to react with water that's in your plasma. And the water is going to donate a hydrogen ion that's going to combine with your CO2, and it's going to make carbonic acid. And whenever you have acid, if you think way back to September when we talked about all of the chemistry with acids and bases, when you have an acid, think about what it does to a protein. Acids denature proteins. And hemoglobin that's carrying the oxygen, it's a protein. So basically, when you change the pH and you make the pH low with this acid, what's going to happen is your hemoglobin is going to denature. It's going to unfold and fall apart. And when it does that, it loses its grip on the oxygen, and then the oxygen is free to diffuse out of the blood into the tissues. So it's all based on chemistry. It's pretty amazing, actually. So it's releasing its oxygen. The oxygen goes from a high concentration in the blood to a low concentration in the tissue, and now you just fed your tissues, your cells. All right, so now we are going to fill out our chart here. We'll come back to that because I'm having technical difficulties. Okay, that's good. Okay, so now we are traveling along in our bloodstream. We have our carbonic acid, which is our CO2 locked up with our water, and our hemoglobin's all blah blah blah, falling apart, totally unfolded, needs to, find its friend oxygen in the lungs. So they're traveling through the bloodstream, and they arrive at the lungs. And when they arrive at the lungs, remember CO2 is in a low concentration now because we've just taken a good deep breath and there's not much CO2 in the air. And so it, again, is an independent soul. It wants to leave the bloodstream. So our CO2 is going to have a reverse reaction where it comes out of solution from the carbonic acid, and it diffuses out of the capillary into the alveoli. So it's going to leave the blood and go into the lungs. And it does that with diffusion. And so when you do that, you've turned your carbonic acid, you removed your acid, and you turn it back into water. So what happens to the protein now, since it's not an acid? It's going to refold. So your hemoglobin folds back up, and now it has the ability to latch on to oxygen. So oxygen in a high concentration in your alveoli are going to diffuse into your bloodstream, and then it's going to latch on to its friend hemoglobin, and then it's going to start all over again. So the blood takes the hemoglobin, the oxyhemoglobin, to the tissue, and then you go right back to where you began. So really, the ability to dissolve the oxygen in your blood all depends on your CO2's presence or absence. It's basically completely governed by what CO2 does, which I think is really awesome. Okay, so let's do this. So on your chart, you have a picture all right, so we'll fill this in and for you visual people. There we go. Okay, so here we have the tissue. So here's our tissue. Sorry, I can't write with a mouse, it's hard. Okay, here's our tissue. It went through cellular respiration, so now we have a whole bunch of CO2 tied up in our tissue. It's going to diffuse out of our tissues into our blood. So here is the bloodstream. Okay. Our CO2, is it going to go into a red blood cell or is it going to go into the plasma? It goes into the plasma. So we have a reaction. And your book has a really big reaction that occurs here, and I'm simplifying it for you. So if you are a chem nerd and things like that make you happy like me, you can look it up in the book. But for now, you just need to know that our CO2 is going to react with the water, which is basically going to donate some little hydrogen ions there. And it's going to create carbonic acid, which is actually H2CO3. Okay? Our carbonic acid is going to change our red blood cell because it denatures our hemoglobin. I'm going to have to practice writing with the mouse. Denatures hemoglobin. Okay? And so now our hemoglobin is going to drop. Oxygen. Bye-bye, oxygen. You're going on a trip to the cell. So there you go. So now our oxygen goes into our cell because our hemoglobin freed it up. Alright, now we go and circulate all around to the lungs. Now we're at the lungs. Here's our lung. Okay, here's our blood still. Ooh, that's a weird V. Blood. Okay, now, first thing that's going to leave, we have our carbonic acid. Oh, I started spelling emission. I went with the abbreviation. Carbonic acid. The CO2 is going to disassociate with it, so we're plucking off our CO2. Now we just have our little hydrogen ions left over, and those basically become water again. And then the CO2 diffuses into our lungs. So now we have carbon dioxide added to the air in the lungs. Also, once that happens, our hemoglobin folds back up. Whoops. And now it's free to accept our oxygen, which diffuses and latches on to our red blood cell. So O2 plus our hemoglobin. Alright, so that's pretty much it.